Elliott Wave Mathematical Applications. Leonardo Fibonacci was a 13th century Italian mathematician. He discovered a sequence of numbers today known as Fibonacci. The Fibonacci sequence is a set of numbers that starts with a 1 or 0 and proceeds based on the rule that each number is equal to the sum of the preceding two numbers. Therefore, 1 plus 1 is 2, 1 plus 2 is 3, 2 plus 3 is 5, 3 plus 5 is 8, 5 plus 8 is 13. The numbers continue on and on until infinity. We can see how Fibonacci numbers are apparent in the structure of Elliott waves. There are two modes of waves, motive and corrective. There are three orders of simple patterns, 5, 3s and triangles. There are 5 families of simple patterns, impulse, diagonal, zigzag, flat and triangle. And there are also 13 variations of simple patterns. Fibonacci also becomes apparent when counting waves. Broken down, waves 1 and 2 form the 5-wave impulse and the 3-wave corrective patterns, making up the 8-wave sequence. The 5-wave impulse and the 3-wave corrective equals 8 waves. Subdivided further, 21 waves make up the impulsive, and the 13 the corrective, totaling 34 waves. We can break it down even further. 89 impulsive, 55 corrective add up to a total of 144 waves. A value related to the Fibonacci numbers is called a golden section. It states that any length can be divided in such a way that the ratio between the smaller part and the larger part is equivalent to the ratio between the larger part and the whole. That ratio is always 0.618. Also referred to as the divine proportion, it occurs throughout nature and can be found in the shape of plants, hurricanes, glaciers, humans and shells. It has also been used in art to achieve balance and beauty in many Renaissance paintings and sculptures. One of the most popular examples is the painting by Leonardo da Vinci of the Vitruvian Man. His work shows how the human body is subdivided into proportionate percentages. The Milky Way has a number of spiral arms, each of which has a logarithmic spiral with a golden section. The golden section is derived by finding the ratio of any number to the next higher one in the Fibonacci series. For example, the ratio of any number to the next higher is approximately 0.618 to 1, and the next lower number approximately 1.618 to 1. 21 divided by 34 is 0.618. 89 divided by 144 is 0.618, and so on. The further along the sequence, the closer the ratio approaches the golden section, known in math as pi, or an irrational number. Pi is the only number that when added to 1 yields its inverse. For example, 1 over pi is the inverse of 0.618, which is 1.618. 1.618 can also be calculated by finding the ratio of any number to the next lower one in the Fibonacci series. For example, 89 divided by 55 is 1.618. Another consistent relationship is between alternate numbers in the Fibonacci series. For example, the ratio of any number to its next alternate higher one is approximately 0.382 to 1, and to the next lower number approximately 2.618 to 1. As we can see, 34 divided by 89 equals 0.382, and inversely, 89 divided by 34 equals 2.618. Ratio analysis is the study that proportional relationships exist between the waves. The rule of divine proportion suggests that the market reacts to this law of nature. So with that said, we can use Fibonacci ratios to target the end of a move. For retracements, the most common ratios are 38.2%, 50% and 61.8%. For projecting wave extensions, the most common ratios are 161.8%, 261.8% and 423.6%. We can also use Fibonacci to calculate time relationships to predict the end of a move. To predict the time target, we count the significant highs and lows which usually are found on Fibonacci numbers. Distances start relatively small and grow as the Fibonacci sequence extends. The start will create a tight clustering and then expand as the sequence unfolds. Time sequences are harder to predict, but when combined with wave formation and ratio analysis, they provide powerful confluence